Okay, so this is still exploration 6.4.1, and this is going to be number 2 and number 3. So number 2 says if a directed segment drawn from point 23 to point 58 describes a vector PQ. Okay, so that would be the first thing you need to do, is draw that. So I am going to, again, this paper's really light, but I think we can make it work. So I'm graphing the vector PQ. P is at 2, 3. And then Q was at 5, 8. 5. So this segment right here, this is P, and this is Q. So this is vector PQ. And then it says, find an equivalent vector OA, which has its initial point at the origin. Last, find the norm. I'll talk about that in just a second. So, if you look at P and Q, we're going to take... Okay, sorry y'all, I had to pause, so I don't remember exactly what I said last, but this vector PQ, a little like side note over here, we need to talk about component form of a vector. So that vector is formed from point P to point Q. We have to change those points into component form to notate basically what the vector, like what directions you go to get the vector. So how we do that, how we set it up in component form, is we take the second x and we subtract the first x, and take the second y and subtract the first y, which is very much like finding the slope of it, okay? And so I'm basically saying from P to Q, I have to go, what do I have to do with my x's? Well, what you'll notice is when I subtract my x's, I go 5 minus 2, so I'm going over 3, right? So I get 5 minus 2, so I get this to be 3, and then in my y value, I take my 8 minus my 3, and I get this to be 5. And this is called component form of a vector, 3, 5. So notice I go over 3 units, up 5 units to get to Q, right? Okay, so what the question is asking is find an equivalent vector that has that same component form, but is OA, and its initial point is at the origin. So my initial point has to be at the origin. So in order to make a vector of this, the same vector, that means I've got to go over 3 and up 5. 1, 2, 3, 4, 5. Now, if I was using a ruler, this would appear to be a little bit more accurate. But that red vector I just drew would be OA, right? Because it has the same component form. That, is 3, 5. Now the points of that vector, O started at 0, 0, and A ended at 3, 5. And then you see if you plug it into this component form equation, then we get the same thing. So that is what your picture would look like. Now the other part of this is finding the norm of a vector. Okay, what the norm is the magnitude of a vector. Okay, and there's some notation you need to know here. So like it says find the vector of this, find the norm of this vector. So we're finding the norm of vector OA. This is how you write it. That's the notation. Okay, and in order to find the norm, what we do is we take the square root of that component form of the vector. So I'm going to take this, and my magnitude would be 3 squared plus 5 squared, and take the square root of that. So I get 9 plus 25, so I get square root of 34. That is the norm or magnitude. You'll see both words used for vector OA. Okay, lastly is number 3, and let me just switch pages since I took up so much room. So number 3 said to find the norm of vector v, which is 4, negative 3. Now on this exploration it uses parentheses. I think it should be these little brackets. So, and all the stuff that I have researched about it, I guess you can see it either way. So just, I guess, be used to both notations. But if we're finding the norm of that, that means I'm going to write it technically here like this. I'm going to find the norm of vector v, which means I'm going to do the square root of 4 squared plus negative 3 squared. Okay, so that ends up being 16 plus 9, square root of 25. So I get the norm or the magnitude of vector v is 5. Okay, so now you're going to move on to the assignment. I'm going to try to do another video, short video or two to help you with that. And then we will finish up vectors before moving on to 651 next time.